Hello, this is Mr. McGovern, and this is the first video in the acceleration series in Level 2 Physics. So we're going to start looking at acceleration through the diagrams of motion maps, which we introduced in the constant velocity series. If you haven't seen the video on motion maps, you should check it out now. So we've got a ball here that's rolling down a ramp, and as you can see, it speeds up. So if I was to take a picture of this sort of every second, this ball, it might look like this. We know it's accelerating because the distance between each photo increases. Okay, and it increases because the velocity, the change in distance every second, increases as well. So acceleration is a changing velocity. It could be an increasing velocity, it could be a decreasing velocity. So with our motion maps, the first thing we always draw on is a coordinate system. And the coordinate system can point any direction. It would make sense to follow the direction of the ramp. And the ball seems to be rolling down the ramp, so let's call positive direction down the ramp. Then we add a dot for each ball, so you can see them there, and then we add velocity arrows, and velocity arrows are usually about half the length of the gaps between each dots. And so you can see those velocity arrows get bigger and bigger. Now, we're going to label these with V's, V for velocity, and the reason is we're going to start adding acceleration arrows. Right, and because we've got two different types of arrows, velocity arrows and acceleration arrows, we need to label them so we clearly see what's going on. I also like to use different colors as well. So the acceleration arrows, they go between two velocity arrows, and they show the change in velocity. So if you're looking at the first smallest velocity arrow, that gets bigger, and it turns into the second velocity arrow, which is larger, right? So there's an increase in the size of the arrow. So that increase is what our acceleration arrow is. It's what we need to do to the first arrow to make our second arrow. If we look at our second velocity arrow, that gets bigger. Again, it increases in that direction to get to the third, and so the acceleration points in the same direction again. Now, all the situations we're going to meet in level 2 for accelerating things, speeding up or slowing down, the acceleration, how the velocity changes, is always the same. And so we show that on a motion map by putting these what's called equality marks on. They're like little equal signs on each of these arrows. That shows that each of them is the same size each. So the velocity changes and the acceleration arrows go in between, and those acceleration arrows are the same size. Okay, so in this case you can see the velocity is positive. It's positive because it's pointing in the positive direction, and it's increasing. It's increasing because each arrow gets bigger and bigger. The acceleration is also positive because it's pointing in the positive direction, and it's constant. It's a constant acceleration. Right, now we're looking at motion map 2. A ball has been pushed and it rolls up a ramp and just slows down as it gets up the ramp. So rolling, rolling, rolling. Again, you can see the distances between the ball are different. In this case, the distances between the ball get smaller and smaller because the ball's slowing down. So for our motion map, I've got the V's on there first. We put our coordinate system, and our coordinate system in this case is going to point up the ramp because that's the way that the ball's going. I could have chosen it to point down the ramp, and in fact I will in the next one. It just seems to make sense. So put dots on, and we put our velocity arrows in there. You can see they're getting smaller and smaller as the velocity gets smaller and the distance between the dots gets smaller, and that means the acceleration arrows point the other way, because if you take our first velocity arrow, the largest one, it gets smaller, right? We have to make the arrow smaller. And the way we represent that is an arrow going the other way, showing that it gets smaller in that direction to make itself into the second velocity arrow, and the same, and the same, and the same. So the acceleration for a slowing down is going the opposite way to the velocity arrows. And that means that in this case, again, our velocity is positive because that's the direction we've chosen as our positive direction, and our velocity is decreasing. Our acceleration, however, is negative because it's pointing in the negative direction, and our acceleration again is constant. So some of you might say, well, I kind of knew that. Positive acceleration means speeding up, doesn't it? And doesn't negative acceleration mean slowing down? I'm going to show you that that's not the case. So now we've got the same situation, exactly the same situation. The ball's going up the hill and slows down to a stop. This time, however, I'm going to choose the coordinate system to be pointing the other way. The positive is down the hill. I can do that because I can choose my coordinate system to be anywhere I want it to be. Now, I put my velocity arrows on and label them. They're exactly the same. Nothing's changed. Even though the coordinate system's pointing down, Nothing has changed with my velocity arrows. My acceleration arrows are the same as well, because they're showing that these velocity arrows get smaller. So they're pointing down the hill still. Now when we look at what we've got here, you find that in this case, velocity is negative. It's negative because it's pointing in the negative direction according to my coordinate system. And the velocity is decreasing. My acceleration, however, is positive. Even though I've got a situation where the ball is slowing down, I have positive acceleration. The acceleration is still constant. Now that should hurt your head a little bit. Positive acceleration does not mean speeding up, and negative acceleration does not mean slowing down. Positive acceleration means acceleration in the positive direction. Negative acceleration means acceleration in the negative direction. So a summary of everything we've come across so far. Always start with your coordinate system, okay? There's no wrong or right answer, but you've got to be consistent the whole time with whatever coordinate system you've chosen. Label your velocity arrows because you're going to have acceleration arrows on there as well. Remember, acceleration arrows go in between your velocity arrows, and they show the difference in velocity. Or they show what is needed to go from one velocity arrow to the next velocity arrow. That kind of means the same thing. A positive acceleration does not mean speeding up. A positive acceleration just means acceleration in the positive direction. And negative acceleration does not mean slowing down. It means acceleration in the negative direction.